So to start Chapter 6, our first section is going to be to calculate the area between two curves. In Chapter 5, we looked at calculating the area between a curve and the x-axis. Now we're actually going to look at two functions and calculate the area between them. So suppose we're given two functions in the form of y equals f of x and y equals g of x. So first of all, when we have equations in the form of the y equals, we're going to be looking at two curves, and the idea is we want to calculate the area between these two curves. Suppose that f of x is greater than g of x. And again, we're looking at some closed interval from a to b, a and b being particular x values. First of all, what we want to do in order to calculate the area, you want to observe that one function is on the top, one function is on the bottom. So when we talk about the area between the two curves, first of all, when we look at our bounds, we're going to be looking at a bound on the left and a bound on the right in form of an x value. So to calculate the area between the two curves, we're going to again integrate from our closed interval a to b, and we're going to calculate the difference between f of x minus g of x. Again, these a and b are our x values. The upper bound is also an x value, and the one thing you want to consider when you look at f of x, it's always the top minus bottom function. So when you're looking at calculating the area between the two curves, you always want to know which function is on the top and subtract it from the bottom. So if the graph is not given to you, you will actually have to graph the function first in order to see which function's on the top versus the bottom. So like I said, our step number one is you've got to sketch your region. So you've got to sketch the region and draw a vertical line segment. What they mean by the vertical line segment is the vertical line segment's there to help you calculate which function's on the top versus the bottom. The y-coordinate on the top endpoint is sketched in step one. Will be your f of x. So again, we always do top minus bottom, your f of x minus g of x. So x equals a is our lower bound. That is the segment furthest to the left. X equals b is the one on the right, and that will be our upper bound. So again, this is going to be our lower bound is a, our upper bound is b. So for example, suppose I want to sketch the region enclosed by the curves and then find its area. So this is an example where, again, the graph is not given to us. We want to sketch the graph by hand because we do not know which will be our f of x minus our g of x. So x squared plus 1 we know is a parabola. Y equals x is a line, and I want to sketch the region from x equals -1 to x equals 2. So here's x equals -1. Here's x equals 2. So when I calculate, first of all, drawing my line y equals x, there's my point -1. So again, I know that this is my straight line here. X squared plus 1 is a parabola, has its vertex at 0, 1, and this is going to have a y value of 2 when x is -1, and then when x is 2, x is 2 and have a y value of 4. So that's what the x squared plus 1 looks like from -1 to 2. So the area I'm trying to calculate the area between these two curves. So that's the area I'm trying to calculate. So now we want to identify the function that's on the top. So clearly the parabola is the one on the top. The line is the one on the bottom. So I'm going to label f of x is the function that's on the top, which is my x squared plus 1. G of x is the function that's on the bottom, and that's my function x. So to calculate the area between these two curves, again, my lower bound x coordinate, again, where these two, the x value that these region is bounded from. The x value is going to be from -1 to 2. And again, it's going to be my f of x minus g of x dx. So again, I'm going to integrate from -1 to 2 of x squared plus 1 minus x dx. So using my rules of integration, I'm going to end up with x to the third over 3 plus x minus x squared over 2. And again, I need to plug in my bounds. I have my definite integral. So that's going to give me 8/3 plus 2 minus 2 squared is 4. 4 over 2 is a 2. Minus, plug in my lower bound. That's going to give me a negative 1/3 minus 1. And again, this is going to give me a minus 1/2. So when I simplify this, that 2 minus 2 becomes a 0, so that's going to give me 8/3. Minus negative 1/3 minus 1 minus 1/2. Again, if I get the common denominator of 6, that's going to give me a negative 2/6 minus 6 over 6 minus 3/6. So 8/3, so that'd be negative 8, negative 11 over 6. That's minus negative 11 over 6. So with a common denominator, again, this is going to become 16 over 6 plus 11 over 6. That's going to give me a 27 over 6, which reduces to 9 over 2. So there's the area between those two curves. Again, if this is a free response question, guys, you can go ahead and leave it alone just right there. You don't even need to do that calculation. So sometimes, again, instead of having lines as the bounds given to you, sometimes they're going to intersect at endpoints. So instead of having vertical lines, they're going to be points. So we have to determine the points of intersection to figure out our bounds. So the way we would figure out our bounds is we would set the functions equal to each other and then solve for x. This is how we'll find our bounds, to find the points of intersection. So find the area of the curves between 2 minus x squared and x. Again, the picture is not given to us, so we want to draw our diagram. So first of all, g of x equals x. That's just our line y equals x. 2 minus x squared, it's a parabola with the vertex going up 2, and it's a reflection, so I know it's going to be opening down. So again, I want to calculate the area between the parabola and the line. So I want to calculate this area right in here. So to find my bounds, you can see we need to calculate these 2 points of intersection. So to find your points of intersection, I'm going to have to take the 2 equations and set them equal to one another. So 2 minus x squared is equal to x. So I'm going to get a 0 on one side. So 0 will be equal to x squared plus x minus 2. So I can factor that into x plus 2 times x minus 1. So x equals negative 2 and positive 1. So then I know this point of intersection is going to be negative 2 comma something. This point of intersection will be 1 comma something. So now you can see which function is on the top. You can see, doing your top minus bottom, this is the parabola is the function on the top. So f of x is the function on the top, which I'm going to define as my 2 minus x squared. G of x is the function on the bottom, which is defined as x. So then to calculate the area between these two curves, again, my lower bound is the x value furthest on the left, which is negative 2. My upper bound is the x value furthest to the right, which is 1. And it's going to be my f of x minus g of x. So 2 minus x squared minus x dx. So again, I'm going to integrate. So that's going to give me 2x minus x to the third over 3 minus x squared over 2. And again, I'm going to evaluate this from 1 to negative 2. So I'll plug in my upper bound, so that's 2 minus 1/3 minus 1/2. Minus, plug in your lower bound of negative 2. That's going to give me a negative 4, and that's going to give me, let's see, negative 2 is negative 8/3. That's going to be a positive 8/3. And that's going to give me a minus 2. And again, if I was to get my common denominators, add them all together, that's going to give me a 9/2. Again, but if it's a free response question, you can certainly leave it alone just like this. So that's how you can find the area between the curves by hand. You may also have to find the area of the curve using your calculators. So here's a nice one where they actually give you the diagram. So they want you to find the region, find the area of region R and region S. So first of all, you still have to know your bounds. So we have to find our points of intersection. So we're going to have to calculate where our points of intersection are going to be. So they're giving me my function. Function f of x is defined here. G of x is 4 to the negative x. So on your calculator, what you want to do, what I always start doing first of all, is I label which function I'm going to load under y1, which one's under y2. So y1, for me, I'm going to type in my f of x, which is the 1/4 sine pi of x. y2 is my g of x, just so I know where those functions are loaded in my calculator. So if I go to my y equals, type in my functions, clear out what I have here. So my y1 is going to be my 0.25 sine pi x. Under y2, I'll load in 4 to the negative x. Now, if you look at the diagram, we're only looking in quadrant 1, so I'm going to adjust my window a little bit. So I'm just going to go from maybe 0 to 5 for my x min to x max. Y min, I'll try from, let's leave it like at -2 to 5. Let's see what that's going to give me. You see how my window range is a little too big, so let me shrink that down a little bit, because really it's just this region right in here. So I'm going to go from 0 to 2. I'll go from -2 to 3. My window's not looking too good here, so let me change that y max to maybe 2, x max to 3. That's a little better. So now, first of all, I want to find these points of intersection. So again, on my graph, I'll go to second calc, intersect, and again, I'm going to find this point of intersection first.